What if I told you that despite all our technological achievements, humanity is trapped in a cosmic prison with bars made of physics itself, and the key to our freedom might not even exist? Right now, as you watch this video, the fastest human-made object ever created, the Parker Solar Probe, is hurtling through space at 700,000 kilometers per hour. Sounds impressive? At that speed, it would still take over 6,000 years to reach our nearest stellar neighbor, Proxima Centauri. We've convinced ourselves that we're explorers of the cosmos, but the harsh reality is that we've barely left our own backyard. Every single human achievement in space, from Sputnik to the James Webb Space Telescope, represents less than 0.001% of the journey to the nearest star. We're not spacefaring pioneers. We're prisoners who've learned to decorate ourselves. Let's confront the brutal numbers. Proxima Centauri sits 4.24 light-years away. That's 40 trillion kilometers of absolute nothingness. To put this in perspective, if Earth were a grain of sand, Proxima Centauri would be another grain of sand located 6 kilometers away. But unlike walking 6 kilometers on Earth, there's no air, no ground, no stopping points, just the merciless vacuum of space. Our current chemical rockets achieve maximum speeds of about 40,000 kilometers per hour. Even if we could sustain this speed indefinitely, a journey to Proxima Centauri would take 114,000 years. That's longer than modern humans have existed as a species. We would need to evolve as a civilization just to complete a single interstellar journey. Here's where physics becomes our warden. To accelerate even a modest 1 kilogram spacecraft to just 10% of light speed would require the energy equivalent of 450 million tons of more energy than most countries consume in a year. For a human-rated spacecraft, we're talking about energy requirements that exceed the entire global energy production for decades. But energy isn't just about getting there, it's about survival. Traditional solar panels become useless beyond Jupiter's orbit, where sunlight is 25 times weaker than on Earth. Nuclear reactors powerful enough for interstellar travel don't exist, and even our most advanced radioisotope thermoelectric generators lose power within decades. We're essentially asking astronauts to journey into eternal darkness with a flashlight that will die before they're even close to their destination. Evolution spent millions of years perfecting the human body for Earth's environment. In space, everything that makes us human becomes a liability. Cosmic radiation, high-energy particles from distant supernovas, bombards travelers with the force of microscopic bullets, shredding DNA and triggering cancers we can't even predict. Zero gravity turns our bones into brittle chalk and our muscles into useless tissue. Studies on the International Space Station show that astronauts lose 1–2 of their bone density per month. On a century-long journey to another star, travelers would arrive as physical shells of their former selves, if they arrived alive at all. But the physical deterioration pales compared to the psychological torture. Imagine complete isolation from Earth, knowing that everyone you've ever loved is aging and dying while you drift through an endless void. No real-time communication, no rescue missions, no hope of return. The human mind simply wasn't designed for such existential horror. Einstein's relativity offers us a cruel joke. Yes, at near-light speeds, time dilation means travelers would age slower relative to Earth. But this isn't a gift, it's a one-way ticket to cosmic exile. Launch a mission to Proxima Centauri at 90% light speed, and the crew experiences perhaps 2 years of travel time. Meanwhile, 5 years pass on Earth. They arrive to find that everyone they knew is gone. Their civilization transformed beyond recognition. This temporal isolation makes interstellar civilization impossible. There can be no galactic internet, no interstellar trade, no unified humanity spanning the stars. Each world becomes an island, forever separated by oceans of time and space. We're not building a galactic empire, we're creating cosmic orphanages. Desperate to escape these constraints, scientists have proposed increasingly exotic solutions. Fusion rockets that don't exist. Antimatter engines requiring technology centuries ahead of us. Solar sails that would need to be larger than entire cities. Wormholes that violate everything we know about physics. The most realistic proposal breakthrough starshots light-propelled microprobes would send rice grain-sized robots to Proxima Centauri in 20 years. But these aren't explorers. They're sophisticated cameras that would send back a few photos before disappearing forever. It's like trying to explore the Amazon by throwing pebbles at it from across an ocean. Some propose generation ships, massive vessels where entire civilizations would live, reproduce, and die during the journey. But this raises horrifying ethical questions. How do you justify condemning hundreds of generations to life in a metal can? What happens when the great-great-great-grandchildren of the original crew question the mission? Do they have the right to turn around? To rebel? To choose their own destiny? These aren't just engineering challenges, they're moral catastrophes waiting to happen. We're essentially proposing to create flying prisons where the inmates are guilty of nothing except having the wrong ancestors. This brings us to the most chilling possibility. We might have discovered why the universe appears empty of intelligent life. The Fermi Paradox asks why, in a universe of billions of stars, we've never encountered other civilizations. Perhaps the answer isn't that aliens don't exist, it's that they're all trapped in their own cosmic prisons, just as we are. Every civilization, no matter how advanced, eventually hits the same wall. The speed of light, the vastness of space, and the limitations of biological life. The universe might be teeming with intelligent life, all of it confined to their home systems, all of them staring at the same impossible distances we face. Yet perhaps this cosmic imprisonment isn't permanent. Throughout history, humans have consistently underestimated the power of exponential technological growth. Quantum mechanics, once purely theoretical, now powers our computers. DNA, once a mystery, is now programmable code. Maybe the breakthrough won't come from bigger rockets or more powerful engines. Perhaps artificial intelligence will design solutions we can't even conceive. Maybe we'll learn to upload consciousness, transcending biological limitations entirely. Or perhaps we'll discover that the universe operates on principles we haven't even imagined yet. The one certainty is this: if we ever do break free from our solar system prison, it won't be through incremental improvements to current technology. It will require a fundamental revolution in our understanding of reality itself, a leap as profound as the discovery of fire, the invention of writing, or the splitting of the atom. Until then, we remain prisoners of physics, explorers of a single room, dreamers gazing through cosmic bars at a freedom that might forever remain beyond our reach. Call to action. What do you think? Are we destined to remain trapped in our solar system forever? Or will humanity find a way to break these cosmic chains? Share your thoughts in the comments below. If this video made you question everything you thought you knew about space exploration, smash that like button and subscribe to BrightBoundX for more mind-bending explorations of the universe's greatest mysteries. Hit the notification bell so you never miss our journey to the edge of human knowledge. The cosmos is waiting, let's explore it together.